Alright, in the periodic table of elements, you have a lot of elements divided into groups, depending on their valence electrons and their families and etc. All their properties. So, the first group, you have one valence electron. Second is 2, 3, 4, and you get the idea after this, 6, 7, 8. So in the last group, the noble gases, which includes helium, neon, argon, krypton, xenon, and so on and so forth, they all have a stable last shell. What does this mean? So, going to the Bohr-Rutherford diagrams, if you know these, it's simply a diagram to draw atoms. And on the last shell right here, the last orbital, if they have full set of electrons that is stable, it's not missing one or has not enough to be full, that means it is not a stable element yet. So, why do elements want to become stable? Elements want to become stable because in order to be stable, they would have to have the last shell full. So this could mean that if you have an example right here for metals, the last shell tends to have like 1, 2, 3, 4, or 5 sometimes valence electrons. So in order for them to become stable, they would want to lose the valence electrons. So that is why metals create positive ions, positively charged ions. What does this mean? Well, just like what I said, if the metals want to lose an electron, if you lose something that's negative, you become more positive. Alright, so now going to the non-metals. Usually this side of the periodic table. Not perfectly accurate, but the non-metals, they usually want to gain an electron as it is closer for them to be stable. So if non-metals want to gain an electron, if you gain something that's more negative, you obviously become more negative. So now that we know that metals create positive ions, this is 100% all the time, and non-metals always create negative ions. So let me give you a few examples. So let me take some common non-metals used in compounds and in biology sometimes. Alright, so let's have oxygen and we have chlorine. These are our non-metals, and then I will do metals in a second. So for oxygen, the last shell is missing two electrons, so it wants to gain 2 electrons because it's easier for an element or an atom to gain 2 electrons than to lose all of its electrons, because it's just a lot easier. Think about it. If you wanted to gain something, it would be a lot easier to gain 2 than to lose 7 or 8. You get my point here. So oxygen gains 2 electrons. That would give it a 2- charge. And chlorine right here is in the second last group, the halogens. So it wants to gain 1 electron, so it becomes a -1 charge. So let me explain what I just did here. So right here, I wrote the 2-. The reason why I wrote 2- instead of -2 is because you would write the amount of electrons that it gained or lost, and then you would write the charge after. Example for here for chlorine, I didn't write a 1 because it is not proper communication. Just like how in algebra, you do not write x to the power of 1 as it is. Anytime you have x alone, it's just indicated that it is to the power of 1. So now let me do some non-metals. Some metals. So now I have sodium. They're very commonly used in a lot of compounds. And let me say calcium. Alright, let me start off with sodium. Sodium wants to lose 1 electron, as it is in the first group. It wants to lose 1 electron. So anytime you lose 1, you just become a positive ion. You do not write the 1, just like how you do not write the 1 in the chlorine ion. So for calcium, it is in the second group, so it wants to lose 2 electrons. So it has the 2 in front. The number of electrons it gained or lost is first, and then you write the charge, which is positive because it lost electrons. Alright, now let me move on to why ions are very, very, very critical for compounds. Alright, let's say we have sodium and chloride. Sodium and chlorine right here. Alright, so let's start off with the sodium. As I just did before, the sodium would create a +1 ion. We do not write the 1 as it is not communication skills, so we write the positive. So the sodium, we know it creates a positive ion. And the chlorine creates a negative ion as it wants to gain 1 electron, so it becomes a chlorine minus. The reason why sodium and chloride react with each other to create sodium chloride, which is table salt, which we use I hope every single day. So these two react in a certain way, and it makes sodium chloride. Alright, you might be wondering why I'm saying sodium chloride. The reason why I went from saying chlorine, right here, that is just chlorine, and now I'm going to chloride, is because chlorine, this is the name of the element alone. Once you have Cl by itself, it is chlorine. Once it gets to Cl minus, once it gains that electron and is now an ion, it becomes chloride. This applies to a lot of elements that we know, such as a lot of the nonmetals. So oxygen, once it becomes that a 2 minus charge, it's going to be oxide. You don't write oxygen anymore. Think about it. Once you say carbon dioxide, the reason why you say dioxide is because the reason why is because you don't say carbon dioxygen. It's because it is the ion. Another example would be bromine. Once it is an once it is an ion, you would say bromide, and so on and so forth. It happens for a lot of different nonmetals. Alright, so why didn't I change sodium? Well, for sodium, what is it? It is a metal. Metals, the name for metals would never change in any type of compound or polyatomic ion, etc. It would never change. Alright, so let me rewrite this in a more visual way. So the reason why sodium, I'll write that in a big ball right here, sodium and chlorine come together. So sodium is a positive, chlorine. The reason why they come together is because a positive and a negative, once they balance each other out, let me write a little balance thing right here. Once they balance each other out, it is perfectly balanced. Think about it. If I have a +1 and a -1, it equals to 0. If I give you an apple and I take it right back from you, how many apples do you have? Obviously a big 0. Alright. This is an example of why ions are very important for chemical reactions and compounds that is very important for our day-to-day lives, such as sodium chloride right here. We use salt all the time, and the reason why sodium and chloride react with each other is because one is positive, one creates a positive ion, which is the metal, which is sodium, and the other creates the negative ion, which is the non-metal, which is chlorine. This was some examples of ions. I showed you how ions are very important for compounds and why some compounds only react because of the positive and negative charges. Alright, thank you guys for watching.